Okay, so today we're gonna use the definition of the convergence of a sequence in order to prove that the limit as n approaches infinity of n plus 1 over n is equal to 1. So first we're going to start with what we want to show, right? So we want to show that for every epsilon bigger than 0, there exists a capital N contained in the natural numbers such that little n bigger than or equal to capital N would imply that n plus 1 over n minus 1 is less than epsilon, right? That eventually after this capital Nth term, all these terms are so arbitrarily close to 1 that the difference between those terms and 1 is arbitrarily small, aka less than epsilon. Okay, so let's go ahead and do some scratch work to find a good candidate for this capital N. So we're going to do n plus 1 over n minus 1 is less than epsilon. So we can rewrite this 1 as n over n, so we can get a common denominator. Minus n over n less than epsilon. And then since we have a common denominator, we can combine the numerator. So n plus 1 minus n over n is less than epsilon. And then this will be 1 over n. The absolute value of 1 over n is less than epsilon. And then, of course, since n is the term of the sequence, right? We know that all those terms go from 1 to infinity, aka they're all positive numbers, right? Natural numbers. So that means that the absolute value of 1 over n is just 1 over n is less than epsilon. And then we could just do 1 is less than epsilon times n. We can multiply both sides by n. And then we can divide both sides by epsilon, right? So 1 over epsilon is less than n. Okay, so that is our scratch work. So from here, now we can start the proof because we have a good candidate for our capital N. Okay, so let's go ahead and start the proof. So we're going to let epsilon be bigger than 0 and choose capital N to be bigger than 1 over epsilon, okay? Where, of course, capital N is a natural number, okay? So remember, we want to start with the assumption that little n is bigger than or equal to big N and eventually get to this over here. So we'll suppose that little n is bigger than or equal to big N. All right, since little n is bigger than or equal to big N, and big N is bigger than 1 over epsilon, this means that little n is bigger than 1 over epsilon, right? Okay, now we got to do some algebra in order to get to here. And I'm going to use my scratch work a little to help me out, right? Okay, so we have that here. Of course, this implies that, let's see, epsilon n is bigger than 1, which implies that epsilon is bigger than 1 over n. Or we can write this as 1 over n is less than epsilon, right? Okay, so this implies that absolute value of 1 over n is less than epsilon. Okay, and of course this implies, so here, look, I have the absolute value of 1 over n is less than epsilon, and now I know that this is the same thing as n plus 1 minus n over n, right? So this is going to be n plus 1 minus n over n is less than epsilon. And then this implies that n plus 1 over n minus n over n is less than epsilon. And then finally, this implies that n plus 1 over n minus 1 is less than epsilon. So notice we got from our assumption n is bigger than or equal to n, and we get to n plus 1 over n minus 1 is less than epsilon, and that is the proof.